So for wireless final exam, first question we have to do is find the diversity gain. Diversity gain was from previous exam, no? You can find my cheat sheet. It is over at the bottom here and trivial included here. Diversity gain is number of transmission antennas and receiving antennas. So there's 3 transmitters, 4 receivers. So it's 4 times 3 is equal to first one. Second one is multiplexing gain. Multiplexing gain, if you go look at the cheat sheet, it is finding the minimum of the TX and RX. So the receiver and the transmitter. So it's finding the minimum between 3 and 4. So the minimum is 3. Next one is ISMO with 2 antennas. If coefficient is given these two, find what should be multiplied to the first antenna to find the maximum ratio. This one is also on my cheat sheet. You can look. It's in the MIMO first page. It's here. Maximum ratio combining right here. And I'll show you how it looks like. So maximum ratio combining is we just have to find the conjugate. So we take the first, it's asking for first, there's first and second here, but we look at first. So you take the conjugate of the first one. So conjugate of this is just flip this symbol to negative, or if it's negative, let's flip to positive. So it becomes 3 minus 4i. Next one is equal gain. Equal gain is, to find equal gain is we have to look at the cheat sheet, is H2 conjugate divided by absolute value of H2 as well. So calculator here. So in order to find it, I recommend you use a calculator to find the absolute value of H2. So we put conjugate, right? So H2 first will be -3 plus 4i. And then this will be the absolute value of -3 plus 4i. To find the absolute value, just have to press shift and then absolute value. And then you put in -3 plus 4i. I is that ENG. And then you get 5. If you just do the absolute value by hand, will be a different result. So this will be 5 divided by -3 plus 4, like that will be the result. And next question, number 5, is finding the total instantaneous SNR. So to find total instantaneous SNR, if you look at my cheat sheet, it is mean SNR times the H1, absolute value of H1 squared, plus the H2 squared, like that. Which, if you plug it in, the mean SNR you are given here is 0.2. So if you plug that in, you will get 10. Okay. Now, so next one is called space-time code. So space-time code, we're trying to find the first antenna that's in the second time slot. So, first antenna. If we look at the formula, if we check the table, I'll show you. If you check the sheet, it shows you that it is, in order to find it, you have to do it's not S1, it is S2. So S2 conjugate negative. This is the result of it. So what you have to do is just negative conjugate this one, which would give you a 3 minus 4i. Okay. Next one is finding the MIMO. In order to find MIMO here, instantaneous value of the first data. So first data is this one. First data, we could write it as H1, right? And find the instantaneous SNR. To find the instantaneous SNR, you have to know that it is equal to the absolute value of H squared times the mean SNR, which is H is 4 squared, right? Sorry, this is 1 times mean SNR. It's given here is 2. Multiply that, we get 32. That's the answer for that one. Mean SNR, I believe it's in my cheat sheet. Next question is MIMO as well. Same thing, but we're trying to find the capacity this time. Capacity of the first data stream. So to find the capacity, the formula for it is the bandwidth times the log base 2 of 1 plus SNR times the H, but that's alpha, that's lambda, sorry. So this would be 10 for the bandwidth, and times log base 2, it's 1 plus SNR of 2 is 2 times the lambda is 4 here in this case, so it would be 4 to the power of 2, and which would give us a value of 50.44. Okay. Now, as for the second one, what is the total capacity? So total capacity here is just finding both the 4 and the 3. So we just add C1 and C2 together. So we repeat the same thing again here. So C total is bandwidth times the log base 2, 1 plus gamma 1 plus log 2 plus 1 gamma, like that. And they're all multiplied by bandwidth. Bandwidth is on for both of them, but I distribute it out, I factor it out, and so plug in the numbers. You would get 10 times 10 as the bandwidth, log base 2, 1 plus 32 plus log base 2 times 1 plus 18. That's it. 18 comes from this one. So notice that C can be written like this as well, or it can be written like this. Notice the SNR times the H. I wrote it as lambda for this sake, so it's the same thing. Sorry if it confuses you, but I simplified it. That we figured out that it's 32 here, and this is 18. So the final result of this would be 92.92. Okay, for broadband multiplexing, we have to find the fraction code. Fraction code is just สัดส่วน so what is the สัดส่วน of the data to speed, so it's 4 to 10. And next one is finding the average packet speed arrival, average rate of packet arrival. So to find this one, you need to know the formula of Poisson. I included one here, so you just have to plug it in here. So the reason why I use Poisson is we have to find the Poisson is used for finding the probability of packet arrival. So whenever we're talking about packet arrival, we are talking about using Poisson distribution. And so Poisson distribution would be that. Therefore, let's see here, we have 3 packets of arriving. So this one would be our K. For the formula here, this would be K. And 1 second, this would be the probability. So it's K. And we are solving for the lambda in this equation. So to write it out, we just down to 8e negative 2 divided by 6 is equal to lambda of 3 times e to negative lambda divided by 3 factorial. So just by looking at this, you can just use common sense to figure out how we could get what value would be up here to get this. So you notice that e is to the power of negative 2 here, right? It's the e to the negative lambda. So we can predict that lambda is equal to negative 2. So this I'm just guessing this is 2, which if I plug it in, it will be correct. So that's one way you can do it. Next one is we're trying to find the average packet length. Average packet length, we need to use exponential distribution formula, which is right here. I put it right here. So to find exponential, it's whenever we're talking about the probability of finding the length of a packet. So packet length, packet arrival. So what do we have? Well, we have the probability and where we have the length. The length here would be x. X is 100 here. I'll switch to, so x is 100 here. And so we're trying to solve for mu, right? Solve for mu. So we have 0.25 e to the negative 25 equal to mu times e to the negative mu 100. And so now it's pretty obvious that what lambda is, mu is, given that it's right here. So we can just deduct from deduction to see that mu is 0.25 right here. So that's the answer. Now for this one, this was a bit tricky. We're trying to find the probability given that the range of 100 and 200. Now we have to use integration for this. You notice here to find the packet length. Whenever you see length, it's always exponential. Okay, so we use exponential distribution, and the formula for it is this one. So it gives the probability. So we need to use integration for this one. So say we have to find the probability of px, we have to find the integration from 100 to 200. Here the range, and the formula would be mu again. Mu e times e to the power of negative mu to the power of x. So x is 100. No, sorry. In this case, we're trying to find mu, right? We need mu for this one, since mu is the average packet length. Average packet length is equal to 100, and to find mu, it's 1 over mu. So we need to flip it around. So mu is equal to 1 over 100. Okay, this is just the way we calculate mu, given that it's an average packet length of 100, all right? And so that would mean it is equal to 1 over 100, which is here, mu times e. So it's mu times e to the negative 1 over 100 times x times dx. Plug that into the calculator, we will get 0.232. So to find the integration is you gotta press integration here, and then you plug in the formula. So it's 1 over 100 times e is alpha to this one, and then to the power of negative 1 divided by 100 multiplied by x. X is just alpha, and then you press the parentheses x here. You go down to 100 here, and then go up to 200 here, enter, you get the result. So you go. So next one is consider the router if the average rate, the packet rate is 2 packets per second, and the packet length is 5 bits. What is the average input bits? So we're trying to find the average input bits here. In order to find it, we need to use the formula in the cheat sheet, which is input bit rate. It's equal to lambda divided by mu. Now what is lambda? What is mu? Lambda is the packet arrival, and average packet length is 1 over mu, which is equal to 5, which makes mu 1 over 5. So lambda is equal to 2 divided by 1 over 5, which is 10. Number 15, we need to find the maximum average packet bit, given that the length of the packet is this and the fiber is that. So whatever we need to do is we need to use a formula that is lambda must be less than, the formula is lambda divided by mu must be always less than C. C is the maximum capacity. C must not be exceeded, but here we're trying to solve for lambda. Because we have the C is one, that, so it is, we'll move mu to the other side here, like this, and then C would be 1 times 10 to the power of 6 times mu, which mu would be 1000, so it'll be 1 over 1000, right? So this is mu, 1 over mu is equal to 1000, which makes mu 1 over, so we get that. Multiply those together, we get 1000 packets per second unit. Oh. Next one, we're trying to find the probability that the buffer is empty. So when we talk about buffer being empty, we jump to the, if it's just normal, we jump to the first cheat sheet formula. So it's the first option. First option's on the left side, and the second option's on here. So probability that the buffer is empty is right here. So we plug the formula here, and then we find, how do we plug it in? Well, average packet length, we figured that out already. It's mu, 1 over mu is equal to 100, and our packets is lambda, it's 100, and the max capacity is 220 times 1000, basically 1000, and no longer than 1000 bits. No longer than 1000 bits would be beta. That's 1000. So in this formula, we have to find rho. Rho is P right here. So in order to find rho, I have the formula here. I stuck it in. So in order to find rho, I just have to put lambda divided by C times mu, and which would give us 0.5, and then we can plug this 0.5 into the formula to get the 0.5 here again. So now we plug all of these into that formula, we will get 0.2. Next one, we are trying to find lowest fraction input. So we have maximum number of users. When we try to find maximum number of users, I have the formula written here, maximum number of users, plug that in. Plug in maximum number of users. We're now able to find each value, which one is what. We have to solve for it. In this case, there's a variable stuck with numbers, so we have to find what n is, basically. So to find n here, we need to find, so n is packet arrival, so it has to be lambda is equal to 100 times n, and not this. Packet length is 100, so it's mu, 1 over mu equals 100, and this one again, C is equal to 10 times 1000, and no longer than 1000 bits, this is beta, and this one is what's called alpha. It's the lowest fraction of input output. Okay, so we know that with all those numbers, just put it into the formula, you get it. You spit you out, you have to solve it. I'll show you how it looks like in a moment. So for this question, we have to find rho again. So in order to find rho, we have to do the same thing, but now this time it has to have an n. So lambda times n divided by c times mu is equal to 100n. I just simplify it, 0.5 n. And so now we have to plug in to find the answer. So this is the formula. It's very nasty, ugly. And how do we find it? Well, the only way is you have to guess, basically. You see here, professor says it's hidden between 4, 5, 6, or 7. So you have to plug in n as 5 and see if it matches this quantity or not. If it does, then that's the answer. The answer I tested out is 6. So there you go. To plug this into the calculator, we need to type in 1 minus E would be here, so it's shift ln E here to the power of 0.5, and then we plug in a random number between 4 and 7. So let's put in, like, let's say 6, and then minus 10, and down here we just go for 1 minus, get 0.9999, so which is true here. So last one, we want to find n again. This time we have to find, given that there's a delay here, which makes us use the second formula here. So the first one is maximum number of users here, but the second one is this one, the delay. So find rho first, we have to find rho, but this time rho is different because rho looks like this, so it's alpha times rho. Alpha times rho we get is, alpha here is 0. Oh no, let's break it down. So average packet rate here is lambda 100. Yeah, there we go. 100 my bad, forgot 100 here. And packet length here, it's 100, so it's mu over 100. 1 over mu is equal to 100, and fiber is C is 20 times 1000, and code fraction, this is sorry, what? It's alpha. Alpha is 0.3, and the delay, beta is 1000, and delay is an letter E. So you can find the maximum users here. We know all the variables, just plug it in and find it out, figure it out. Same thing, we don't know the number, we have to guess between 1 and 4 and 4, 5, 6, 7. Plug in the numbers, you guess it. it? Probably, I'm guessing it's probably 5. No, can I guess? You figure it out. I don't know. The rest, broadband switching questions, Professor said it won't be on the exam, but if you want to look at it, go ahead. Give me a guess. I'm not going to cover it. Last 3 questions. How do we find OFDM? The third frequency, you just add 2 plus 4. Frequency 1, frequency 2, you get 6. And what is the steps for OFDM transmitter? Whenever you see OFDM transmitter, I have the answers for this question. It is the inverse discrete Fourier transform. So this is the answer. And for the receiver, it has to be the reverse of inverse discrete. It has to be discrete Fourier transform. So it's discrete Fourier transform here.